Before we start, if today is your first time on my students class channel, don't forget to subscribe and click the notification button so that you'll be promptly informed anytime we upload a new video. And hey, one more thing, click the like button so that the video can reach a lot of people. Thank you. Now let's continue. We had a triangle, that is a right angle triangle here, and we solved this. But in the second method, we can also use vectors. So let us get back to the question and write the vectors here. So the question says that two cyclists left a point P at the same time. The first cyclist covered 300 meters on the bearing of 296 degrees. So let us say that we have the data here already. So first cyclist is 300 meters, 296 degrees. So let's say the first cyclist moved from P to A. He moved from P to A. So the first cyclist began from P to a certain point A. So P to A, that is vector PA, is going to be, the distance is 300 meters and the bearing is 296 degrees. Now let's get to the second one too. The second one, it says that and the second cyclist covered 250 meters on a bearing of 206 degrees. So we have that one also here. So let's say the second cyclist also moved from the same point P, but he moved to B. So we have PB, and that is 250 meters, 206 degrees. So these are the two bearings that we have here, and the question says that you have to calculate the distance between the two cyclists. So that is to say that we have to find the distance between the vector AB or the vector BA. So we should know that the magnitude or the distances are the same between A and B, but AB vector is different from BA vector. That is when it comes to the direction or the bearing. So because the second question says that find the bearing of the second cyclist from the first, we are using AB, not BA. And I want to emphasize this. Now, if we write AB, we mean the bearing of B from A. So when we write BA, then we mean the bearing of A from B. So the first point is where we begin. And if you look at the question, the B says that we have to find the bearing of the second cyclist from the first. So the point of the first cyclist is A. So because it says from the first, in other words, from A, we will be using the vector AB here so that it can be very easy for us. So we are going to find vector AB, and we will use resultant vectors to express vector AB. Now vector AB can be expressed, if you look at the two vectors that we have here, we have vector PA and vector PB. And if you look at it, we have 3 points here. We have the point A, the point A is here, we have the point B, the point B is here, and we have the point P. So these 3 points combine to give us vector PA, because we can have P and A, and vector PB, we can have P and B here. So we have 3 points here, and we're going to look at how we can combine these 3 points by using an idea we call resultant vectors. So with resultant vectors, it means that you can begin from any of the points, but if we are finding the vector AB, the first point should be A, and the last point must be B. So that is what we mean by resultant vectors. That is when you move from one point to the other, the second vector, the initial point must begin from there. And I'm going to show you, that is what I mean. Because it is AB, I have to begin from A. Alright, and because I have 3 points, I cannot move from A to B at once. I have to move from A to P, because the last point has to be B. So I will say AP, and I'll say vector AP. Then I'll say plus, but because here I have moved from A to P, the next vector must begin from this P. So I'll say from P, and now I can move to the last point here. So it's something like A to P, then to B. So A to P, then from P to B, so that I can have AB. So I'll write B also here, and I'll have vector PB. So vector AB can be expressed in terms of these two vectors, that is AP plus PB, and the points here must be the same, and the points beginning and ending must also be the points that form the vector here. So let us see how we express the vector AP. Now we have been given the vector PA, not AP. We don't know AP, but we know PA. But let me tell you this, the vector AP, if we want AP is equal to the negative of the vector PA. Now we call this inverse vector, or we call it the negative vector. what we mean is that if you have any vector and you negate it, it changes direction, but the magnitude is the same. For example, the vector AP means from the point A to the point P. So if I move from A to P here, if the distance from A to P is say 10 centimeters, if I move from P to A, it will be the same as 10 centimeters. But the moment I negate the vector AP, it will change to the vector PA. So I want AP, but I've been given PA here. So this is what I'm going to do. I'm going to say, now AP is the same as the negative of the PA, I know here. So, and PB, of course, I know PB here because the second one says that it moves from P to B. That is the second cyclist. So here PB is known. So that is not going to be any problem. So let me express this in column vector. These vectors have been given in a form we call magnitude and bearing. So I want to express them in column or component form. So let me put the negative sign here and let me express the vector PA in its component form. So PA is here. So you write the distance 300 or the magnitude of the vector, then you add sine of the angle, that is 296. Then you also write 300, then you add cos of the angle 296. So that is all. Plus, and I'll go to the vector PB. The vector PB is the same thing here. So here there is no need to negate it because the direction is the same. So I'll write 250, then sine of the bearing, that is 206. Then I'll write 250 again, then cos of the bearing, that is 206. So when I get here, let me put the negative here so that it becomes very clear. And here I'm going to type 300 sine 296 on my calculator. 300 sine 296, and when I press on the equal sign, I have negative 269. So I will resolve it to just two decimal places. So I have negative 269.64. So negative 269.64, and I'll check the next one too. Cos 296. Okay, so that is 131.51. 131.51 plus, so let me get to this, 250 sine 250 sine 206, and that is also negative 109.59, negative 109.59. Then 250 cos, so I have cos 206, and that is negative 224 point. All right, so that is 0.69. There is 8 here, so 0.70. So that's going to be negative 224.70. All right, so let me now expand these brackets. I'll deal with the negative sign I have here. So negative times a negative, so that'll be negative, so I'll have a positive 269.64, and negative 1 times 131.51, I'll have negative 131.51 here, plus I'll have negative 109.59, then here will be negative 224.70, and this will be equal to, so I'm going to add the first part, that is the x coordinates. So I'm going to have something like this. I'll have 269.64 plus negative. So plus negative, I can do this, or that is the same as just type in minus 109.59, and that is a fraction, so you press on SD, and that is 160.05, 160.05. Okay, and let me check the other one too. Negative 131.51. Then I have plus minus, so let me say minus. All right, this time let me type this for you to see. Plus minus is the same as just writing minus or typing minus. 224.70. 0.70 is 7, and you have negative, so you press on SD, then you have negative 356.21, so you have negative 356.21. So that is the vector AB. So let me put the vector AB here. So this is the vector AB, and I want the distance from A to B. So I'm now going to find the magnitude of the vector here. So I'll say vector AB, and I want to know its magnitude. So I'll take the square roots and I'll square the individual components. So 160.05 squared plus negative 356.21 all squared. So let me put the square root over it again. All right, let me type the whole of this and see. And if I type this, when I use the plane geometry, I had 391 meters to 3 significant figures. So that is what I had. So when I type this, I should be having 3912 or something like 390 point something, and I will convert it to 3 significant figures. So I'll press on the square root sign and I'll open bracket 160.05. I'll close it and square it. I'll add in bracket again negative 356.21. I'll square it again and I'll press on the equal sign. So I see 390.51. Let me put it that way. 390.51 meters. So I have to convert this to 3 significant figures, and to do that I'll be counting from the first non-zero digits here. So that is going to be 1 2 3, but because that is 5, I'll add 1 to this and that'll be 391 meters. So that is to 3 significant figures. So you can see that in my first solution I used plane geometry and I had 391. Even here I had 390.51 meters before I converted, and you can see the same thing here, 390.51 here. So you can use plane geometry to solve this. That is when I invoked Pythagoras theorem, or you can as well use vectors to solve this, and that is pretty easy too. So let's look at the second one here. The second one says that I'm to find, sorry, the B says that I'm to find the bearing of the second cyclist from the first. So the second cyclist, the first cyclist got to the point A, the second cyclist got to the point B. So from the first means that I would start from A. So I'm going to use the vector AB, and of course I know the vector AB, so that's going to be pretty simple here. So let me go back and take the vector AB. That is the vector AB. But talking about bearings, you cannot find bearing without drawing your Cartesian plane or your XY axis. So I have to use this to find my bearing, and that is what I'm going to do here. So let me get my XY plane here. Now the X part is positive, so that means that is on the positive side of the X axis here, and the Y part is negative, so that is going to be in the fourth quadrant here. So I will have 3160 here, so 160.05, and I'll have negative 356.21. so it's going to lie somewhere here, and I'll take it through here. So that is the vector, and you know I want the angle or the direction or bearing is from the north till I cut this place. All right, so the whole of here is 90, so what I need is this small angle here. So let me put theta here. Okay, so I'll connect this to this. Now from here to there, that is the x-axis, so the distance here is 160.05, and that is the y parts, and that is 356.21. So this side, that is 90 degrees and it faces this side, so that is the hypotenuse. So I know these two sides, and theta is opposite to this side, so this side becomes the opposite side and theta is adjacent to this side. So I will use trigonometric ratios, SOHCAHTOA, and the one I can use here is tan. So I will say tan of theta is equal to the opposite side, which is 356.21, over the adjacent side, which is 160.05 here. All right. And there is one thing I want to say here. Most students make a lot of mistakes. Now, instead of writing 356.21 over 160, because the 356 is on the negative side of the y-axis, they will add negative here. No, you don't add negative there. Now, the reason is pretty simple. The negative shows direction. And of course, I want you to think about it. How can you tell me that the length of a right angle, or let me say a triangle, because there is a right angle triangle, right? And there is this, one side of the right angle triangle, and we cannot have measurements of a length in negative. So you cannot tell me that the side or the length of the side of a triangle is negative 356. You cannot measure something from here to there and tell me that this is negative 10 centimeters. No, we do not measure in negatives. You can't measure distance in negative. So what is the importance of the negative sign? The negative sign only shows you the direction of the vector. So if you understand that when you are dealing with trigonometry, tan, sine, cos, you are expressing an angle in terms of the size of a plane figure. The right angle triangle that you see here is a plane figure. So in a plane figure, the size of a plane figure cannot have measurement in negatives. So please don't bring the negative sign if you are expressing or finding the angle here. Most students do that, and that is absolutely wrong. So don't do that. Okay, so let us find the angle theta. To get rid of tan, we have to take the tan inverse of this. So tan inverse of 356.21 divided by 160.05. So let me pull up my calculator and type this one also. So it's gonna be something like this. To type tan inverse, you first press on shift, so shift, then you press on tan so that you have the tan inverse here. So 356.21, then you press on divided by 160.05, and you press on the right cursor key and close it nicely. Then you press on this, so that is 65.80. So 65.80. So the angle we want, that is the bearing, is from the north here till we cut this. So this small angle is what we have had here, that is 65.80. So this implies that the bearing is going to be the 90 here, then plus the theta. So that's going to be 90 plus 65.80. And when we add 90 to 65.80, this is what we get. So this plus 90, and we have 155.80. So 155.80 meters. Oh, sorry, that is angle. Sorry, so that is degrees. And we have to convert this to three significant figures. So 1, 2, 3. But because this is more than 5, we add 1 to this. So that will be 156 degrees. That is to three significant figures.